Alright, so this is our Honors Chemistry lesson video for section 9.1. And I like to put 9.1 and 9.2 with chapter 7 because we learn how to name ionic compounds in 9.1 and 9.2. So we'll eventually come back to 9 and kind of review and finish up learning how to name acids. So we'll do part of 9 with chapter 7, part of 9 with chapter 8, and then we'll kind of just, do a review for chapter 9. So, the system used in naming substances is called chemical nomenclature. A monatomic ion is a single atom with a charge. So, for example, Na with a positive charge or O with a 2 negative charge. When naming a cation, the name of the element does not change, just like we talked about in chapter 7's lesson video. So, K is potassium. K with a positive charge is still just potassium. But when you name an anion, which is a negative ion, the ending of the element changes to I. So O is oxygen, but when O has a -2 charge, it becomes oxide. So again, we talked about this in chapter 7, so this is just a review. So now we're just going to put the ions together. So a polyatomic ion is a group of atoms with an overall charge. So for example, SO4 with a -2 charge. So the sulfur and the 4 oxygens all together have a -2 charge. Most polyatomic ions end in ate or ite. The ending does not change when naming a compound, unless it's an acid, which we'll talk about later. And by later, I mean in section 9.4. Okay, so I'm not going to change SO4 as sulfate. When it's -2, it's still just sulfate. That's just the name of the polyatomic ion. So the ate suffix indicates that the polyatomic ion contains one more oxygen than the polyatomic ion with the ite suffix. So sulfate is SO4 -2, whereas sulfite is SO3 -2. But the problem is that ate and ite doesn't say there's necessarily 4 and 3 oxygens, because nitrate is NO3 with a -1 charge, and nitrite is an NO2 with a -1 charge. So it just indicates that there's one more oxygen. It doesn't actually tell you the number. So just use that when you're trying to learn those polyatomic ions. So it says, based on the formula for the sulfate ion, predict the formula for the following. Remember that sulfur and selenium are in the same group. So sulfate is SO4 with a -2 charge. So since selenium is in the same group, it's going to react similarly to sulfur. So since we know sulfate is SO4 -2, the selenate ion would be Se, because Se is selenium, O4 -2. And then sulfite is SO3 -2, so selenite should be SeO3 -2. So remember, elements in the same group on the periodic table have similar properties, and so they tend to form similar type ions. All right. So maybe pause it and try this one. So it says the formula for the bromate ion is analogous to that for the chlorate ion. Write the formula for hypobromite and perbromate ions. Alright, so I'll assume you've paused it. And remember, you have a polyatomic ion chart in your packet in case if you need to pull that out. So we need to write it for hypobromite and perbromate. Well, hypochlorite is ClO negative. So hypobromite would be BrO negative because chlorine and bromine are in the same group. Perchlorate is ClO4 negative. So perbromate should be BrO4 negative. Just like that. Alright, so hopefully you got those two right. You didn't actually need the hypochlorite and perchlorate ions. I was just showing you where I got my answers from. So there's my answers. So for naming, there's 4 systems that we use for naming, and it depends on what the compound starts with. So the compound could start with hydrogen. In that case, most likely it's an acid. We'll talk about those in section 9.4. It could start with what we call a regular metal, which are pink on my periodic table. That's what we're about to learn right now in section 9.1. It could start with a transition metal or any other ion that can have more than one charge. So notice it's not just groups 3 through 12, which is the transition metals. It's the metals up under the stair step, except aluminum, that's a regular metal, and it's your lanthanides and actinides. So all of those can have multiple charges, so they have a different method for naming. And then it could start with a non-metal, which of course are on the right of the stair step, including hydrogen, but most of the compounds that I give you that start with hydrogen are going to fall in the acid category. Alright, so for this lesson video, we're going to learn how to name compounds that start with a regular metal, which means it starts with something from group 1 that's not hydrogen, or group 2, or aluminum. So the regular metals are located in groups 1 and 2, but not hydrogen, and aluminum. When naming a compound that starts with a regular metal, you just name the metal or the cation and add I to the nonmetal or the anion. So for example, NaCl, Na sodium, Cl is chlorine, but we'll call it chloride. Remember, the positive one will always be listed first, so you don't have to wonder which one's negative. The second one will be negative. If the anion is a polyatomic ion, though, you do not change the ending. So Ca is calcium, CO3 is carbonate. So I just call it calcium carbonate. Alright, so let's look at some together. Alright, so Na is sodium. So I'm going to put sodium, since it's first, it's the positive one. O is oxygen, but because it's second and the negative one, I'm going to call it oxide. Now notice I didn't do anything with the 2. When it comes to ionic compounds, we don't need to take into account the subscript. Alright, so our next one. Al is my first one, so it's just aluminum. And Br is bromine, but because it's listed last, that means it's negative, so I'm going to call it bromide. So don't forget those I endings. Alright, and then our last one has a polyatomic ion. So Li is just lithium. And SO4, it's on your polyatomic ion sheet, is sulfate. So notice I'm not going to change anything about that. I'm just going to write sulfate. Don't change the ending of a polyatomic ion to "ide" when you're naming an ionic compound. Alright, so let's look at a couple more and see if you can do it on your own. Alright, so maybe pause the video and try these. I'll assume you've done that. And let's look at them together. Alright, so Li is my first element. That means it's positive, so I'm just going to call it lithium. NO3 is a polyatomic ion. It's called nitrate. So again, notice I'm not going to change the ending of the polyatomic ion. Alright, my next one, Ca is my first one. It's positive, so I'm just going to call it calcium. PO4 is a polyatomic ion, so I'm going to call it phosphate. Remember, if the second element is a polyatomic ion, you don't need to change the ending to I. Alright, hopefully you got those right. Let's see if you got the last one right. The last one's a little tricky. So it actually starts with a polyatomic ion. NH4 is called ammonium. And then it ends in oxygen, which means oxygen's negative, so it's oxide. A lot of people, for some reason, once you get used to the polyatomic ion being second, they forget to change that ending to "ide" if it's not a polyatomic ion. Alright, so hopefully you got all 3 of those right and you're finding this pretty easy. Naming is pretty easy. The problem is once you learn all 4 types, that's when it gets easy to kind of mix them up. You'll mix up the rules. So definitely you'll want to color a periodic table like this so that you can see like when you're using which set of rules. So remember, the rules I'm teaching you right now only apply to compounds that start with one of the pink elements. Alright, so let's go back. Alright, so we learned how to write the name. You just name the first element, add I to the second element unless it's polyatomic ion. But now we need to be able to write the formula. So when writing the formula for a compound that starts with a regular metal, you must balance charges. That's the most common thing people forget. So on the test, if I put aluminum bromide, a lot of people give me AlBr because they think, oh, well, I wrote aluminum and I wrote bromide, that must be the right answer. But you have to take into account your charges. So aluminum has a positive 3 charge, bromine has a negative 1, so I cross my 3 down. So you should end up with AlBr3. Okay, so remember about crossing charges or balancing charges from our 7.2 lesson video. And don't forget about how to figure out what charge each element has based on what column it's on the periodic table. So let's look at a couple together. So it says aluminum chloride. So aluminum is Al. It's in group 13, so it has a positive 3 charge. Chloride is Cl. it's in group 17, so it has a -1 charge. Since +3 and -1 don't cancel, I need to cross my 3 down. And so remember, when I'm checking these answers, I'm checking for the subscripts. You can leave the charges if you want, but you don't really need them there. All right, so our next one's calcium acetate. So calcium Ca, it's in group 2, so it has a +2 charge. Acetate is on your polyatomic ion sheet. It's C2H3O2 -1. Don't let acetate throw you off just because it's a little longer than the others. It works the same way. +2, -1 don't cancel. I need to cross the 2 down. So remember, if you need to add a subscript to a polyatomic ion, you just put it in parentheses. All right, and then last one, lithium fluoride. So lithium is Li. It's in group 1, so it has a +1 charge. And fluoride is F. It is in group 17 and has a -1 charge. Positive and negative cancel, so I don't need to do anything with subscripts. So this, again, is exactly what we did in 7.2. That's why I teach these sections together. All right, so maybe pause the video, try these real quick, and I'll assume you've done that. Let's look at them together. So we have calcium hydrogen carbonate. So calcium is Ca. It's in group 2, so it has a +2 charge. Hydrogen carbonate is one of your polyatomic ions. It's HCO3 -1. So I need to cross my 2 down, but since this is a polyatomic ion, I just put it in parentheses. So hopefully you got that one right. All right, our next one's aluminum oxide. So aluminum is Al. It's in group 13, so it has a +3 charge. Oxide is O. It's in group 16, so it has a -2 charge. So I have a +3, -2, that doesn't cancel, so I take my 2 and cross it here. I take my 3 and cross it here. Remember, when you're balancing charges, you bring down the number only, not the positive or negative sign. All right, hopefully you're getting these right so far. So last one is cesium oxalate. So cesium is Cs, it's in group 1, so it has a +1 charge. Oxalate C2O4 -2, that's on your polyatomic ion sheet. So I have a +1 and a -2, that doesn't cancel, so I need to cross my 2, just like that. All right, so again, it's the same crossing charges that we did in section 7.2. All right, so section assessment. What are the usual endings for the names of polyatomic ions? Remember, not all of them end in it, but most of them tend to end in ate or ite. So there's a few exceptions like hydroxide, cyanide, ammonium, things like that. So number 2, how does a polyatomic ion differ from a monatomic ion? Well, a polyatomic ion is many atoms bonded with a charge. So it's many atoms bonded with a charge. So for example, CO3 with a -2. So you have C and 3 O's bonded with a charge of -2. A monatomic ion is one atom with a charge. So for example, Na positive, that's an example of monatomic. All right, so number 3 says write the formula for these binary compounds. So remember, the important thing is when you write the formula, you have to remember to cross charges. All right, so we have beryllium chloride. So beryllium's Be. It's in group 2, so it has a +2 charge. Chloride is Cl. It's in group 17 and has a -1 charge. So I cross my 2. Here we have cesium sulfide. Cesium Cs. It's in group 1, so it has a +1 charge. Sulfide is S, it's in group 16, so it has a -2 charge, so I cross my 2. Sodium iodide. Sodium is Na, it's in group 1, so it has a +1 charge. Iodide is I, it's in group 17, so it has a -1 charge, so I don't need to cross anything. They already canceled. And then last one, strontium oxide. Strontium is Sr, it's in group 2, so it has a +2 charge. Oxide is O, it's in group 16 and has a -2 charge. Again, because +2 and -2 cancel, I don't need to cross anything. Remember, if you accidentally cross, you have to reduce, otherwise it's not right. So balancing charges is the #1 thing that people forget. All right, Alright, so it says write the formula for these compounds. So we have sodium perchlorate. So sodium is Na, it's in group 1, so it has a positive 1 charge. Perchlorate is a polyatomic ion. It's ClO4 negative. So since I have positive and negative, it cancels and I don't need to cross anything. Alright, next we have magnesium hydrogen carbonate. So magnesium is Mg, it's in group 2, so it has a positive 2 charge. Hydrogen carbonate is on your polyatomic ion sheet. It's HCO3 negative. I need to cross that 2 down, but since this is a polyatomic ion, I have to put it in parentheses. Alright, next one, calcium acetate. I think I actually had this one previously in my PowerPoint. Oh well, we'll do it again. So calcium is Ca, it's in group 2, so it has a positive 2 charge. Acetate is on your polyatomic ion sheet. It's C2H3O2 negative 1. So I need to cross the 2, but since this is a polyatomic ion, I need to put it in parentheses. Alright, so number 5, the last one says identify any incorrect formulas and explain your answer. So the best way to identify an incorrect formula is to check the charge crossing. Okay, so magnesium has a positive 2 charge because it's in group 2. Sulfate's on your polyatomic ion sheet, it has a negative 2 charge. So, should we have crossed anything? No, that's what's wrong. Whoever made this formula clearly must have thought that magnesium had a positive 3 charge. So there shouldn't be any subscripts here. Okay, so this is definitely incorrect. Next one, Rb, rubidium, is in group 1, so it has a positive 1 charge. As, or arsenic, is in group 15, so it has a negative 3 charge. So yes, we would have crossed that 3 down. So B is actually correct. So I'll put a check by it. Alright, for part C, beryllium is in group 2, so it has a positive 2 charge, and chlorine is in group 17, so it has a negative 1 charge. So what should have been crossed down here is not a 3, it should have been a 2. So for this one, it was incorrect because they clearly crossed the wrong number down. And then for part D, Na, sodium, is positive 1, and fluorine is negative 1, or fluoride is negative 1. So we don't need to cross anything, so that would be the correct formula. Alright, so again, the important thing to remember is these rules that I just showed you now work for naming compounds that start with a regular metal, which remember is groups 1 and 2, but not hydrogen, and aluminum on the periodic table. So if you want to see how to name the other ones, then watch the other videos because I'll go through each type.